The second theory of vector fields, it is Stokes theorem. Stokes theorem, it's the problem. Again, we want to calculate the circulations when I have vector field by this direction. The contour, as we see, from the AB equal the line integration, which is called the circulations, A vector dot dl. It is equal to the integration, line integration, ax dx plus ay dy plus az dz. This is equal to C, the contour of A, B. It is minus A sub y of x dy. And the contour of CD, it is a plus A sub y of x plus dx dy. I will edit the two equations to obtain ay of x plus dx minus a sub y of x dy. And this is equal to the partial of a sub y over partial x dx dy, like the Taylor, which is I do it in the last theorem. Again, I will calculate the line BC, which is equal to the minus a sub x of y plus dy dx. This is dx. And the contour of dA is equal the plus a sub x of y dx. Again, I will adding them. I will get the minus a x of y plus dy plus a sub x of y, all of them, dx. And this is equal to the minus partial ax over partial y. Let's give in this equations number 1 and this equation number 2. Now, equations 1 plus equations 2, we get the partial a sub y over partial x minus partial ax over partial y, or partial y, dx dy, dx dy. This is the curl of a in the directions of the z, in the direction of the z. And this is the area in the directions of the z. Now, in general, I can say that the partial az over partial y minus the partial ay over partial z can be the curl of a in the directions of x and the partial a sub x over partial z minus the partial az over partial x, which is the curl of a in the directions y. Finally, the partial of az ay over partial x minus the partial ax over partial y equals the curl of a in the directions of z. These equations, I can written it by the matrix A, the curl A, equal to the ax hat, ay hat, az hat, the partial x, partial y, and partial z for a sub x, a sub y, and a sub z. So, the curl A equal to the line integrations vector field dot dl. It is the circulation. And this is equal to the surface integration of curl A dot ds dot ds. And this is the circulation density. Circulation density.